Hello everyone. Here let me solve GATE Engineering Mathematics questions of the year 2018 for all branches questions. The questions are related to calculus topic, in particularly maxima and minima of one variable and two variable functions. My videos covered solutions of all branches questions. I already upload the concept video. I give the link in the description box. If you want to learn the concept, then you can watch. Now let's move on to the problem. The first problem is at the point x equal to 0, the function f of x equal to x cube has. You have to check the function f of x equal to x cube has the local maximum or minimum or neither local maximum nor local minimum at the point x equal to 0. You have to check the point x equal to 0. This question is from C department. It has 1 mark. Now the function is f of x equal to x cube. F dash of x equal to 3x square. Solve the equation f dash of x equal to 0. We get the point x equal to 0 is a critical point. Now I find f double dash of x equal to, what is that, 6x. So f double dash of this is x equal to 0 is a critical point. F double dash of 0 equal to 0. So in this problem, second derivative test doesn't give the answer. So here I use first derivative test. What is first derivative test? Suppose that C is a critical number of a continuous function f. If f dash changes from positive to negative, then f has a local maximum. And if dash changes from negative to positive at C, then f has a local minimum at C. So I check the interval. What is the interval? Here x equal to 0 is a critical point interval and f dash of x and sign. What is positive or negative? Interval is x less than 0 one interval and x greater than 0 is another interval. X less than 0, f dash of x is positive. In all the cases, f dash of x is positive only. Negative also positive because x square. Here x square is available. X greater than 0 also positive. Here no changes. Sign changes. Okay. Positive, positive. So the answer is neither local maximum nor local minimum. So the answer is option D. Option D is the correct answer. Now, second problem. If let f of x equal to one function is given, the maximum value of f of x over the interval also given, is dash up to 1 decimal place. This question is from EE department. It has 2 mark. Now first I find the f dash of x first derivative. So this is 9x square minus 2 sevens are 14x plus 5. Next, I solve the equation f dash of x equal to 0. I got the critical points. This is 9x square minus 14x plus 5 equal to 0. Solve this quadratic equation. I got the points x equal to 1 and 5 by 9. The critical points are 1 and 5 by 9. And end points are 0 and 2. End points 0 and 2. Here 1 and 5 by 9 lies inside the interval. Next, I find the f values at the points. What are the points? Critical points and end points. So first I find f of 0. This is end point, starting point. This is 6. And I find f of 1. The value is 7. Next, f of 5 by 9. Substitute the value of x in 5 by 9. X 5 by 9. In f of x, I got 7 point something. 132. F of 2 equal to 12. The maximum value of f is 12. This is maximum value. You have to find the maximum value of f only. So the answer is 12. The final answer is 12. Now let's move on the third problem. Consider two functions f of x and g of x where x is real, the smallest value of x for which f of x equal to g of x. This question is from IN department. It has 1 mark. First give the condition f of x equal to g of x. So x minus 2 whole square equal to 2x minus 1. Here I solve this equation. I got some values. X square minus 4x. X minus 2 whole square is x square minus 4x plus 4 equal to 2x minus 1. So finally I got x square minus 6x plus 5 equal to 0. I solve this equation. I got x equal to 1 and 5. So the value of x is 1 and 5, for which f of x equal to g of x. Okay, here find the smallest value of x. So the smallest value of x equal to 1. The smallest value of x equal to 1. Answer is 1. This is the final answer. Now the fourth problem is a rectangular box without top cover having a square base is to be made from a sheet of 108 square meters. Then the largest possible volume of the box in cubic meter is dash. This question is from XE department. It has 1 mark. Now V equal to, you have to find the largest possible value. We have to find the largest possible volume. So I take the function V equal to volume of the cubic meters. Okay, sorry, volume of the cubic box. Okay, so that is x, y, z. X, y, z. Next, one condition is given. A rectangular box without top cover having a square base is to be made from a sheet of 108 square meters. Okay, so the surface area of this box is 2x z plus 2y z, this is 2, plus xy equal to 108, because without top cover, so here xy only equal to 108. This is the subject to the constraint. This is the function f. Here I use Lagrange multiplies method to find the maximum and minimum value of f of x, y, z subject to the constraint g also given. Find all values x, y, z and lambda such that let del f equal to lambda del g. Del means gradient of f. Okay. And g equal to k. G of x, y, z equal to k. Evaluate f at all the points of x, y, z that result from step A. The largest of these value is the maximum value of f. Maximum value of f. The smallest is the minimum value of f. This is the procedure of Lagrange multipliers methods. Okay. So first I find here f is v and g is this 2xyz plus 2yz plus xy equal to 108. So first I find del v equal to, this is not gradient, del v equal to lambda del g. Here g is this function. This gives g of x y z equal to g2 xz plus 2yz plus xy. So del v equal to lambda del g gives first del v y z, that is dou v by dou x I vector y z I vector plus dou v by dou y j vector, that is x z j vector plus dou v by dou z k vector x y k vector. This is del v. Next, lambda into del g. What is the value of del g? That is 2z plus y. Because del g is first term is dou g by dou x into I vector. That is 2z plus y. Similarly, 2z plus y I vector. Similarly, I got 2z plus x j vector, 2x plus 2y k vector. Solving, comparing the I, j, k coefficients, I got three equations. First equation is yz equal to lambda into 2z plus y. Yz equal to lambda into 2z plus y. I can write, multiply x on both sides. I got x, y, z equal to lambda into 2xz plus xy. This is the first equation. Next is comparing j vector. I got coefficient of j vector. I got xz equal to lambda into 2z plus x. 2z plus x. This gives, multiplying y on both sides, I got xyz equal to lambda into 2yz plus xy. This equation is second. Comparing the k coefficient, k vector coefficient, I got xy equal to lambda into 2x plus 2y. Multiplying z on both sides, I got xy z equal to lambda into 2xz plus 2yz. This is third equation. And using this equation also, this is fourth one. Solving these four equations, finally I got the x, y, z value. Okay. Comparing 1 and 2. This is xyz and this is also xyz. So comparing 1 and 2, I got 2xz plus xy equal to 2yz plus xy. So xy also cancel. Again lambda first cancel. Next xy cancel and z also cancel because z not equal to 0. Finally I got 1 and 2. 1 and 2 gives x equal to y. Since reason is z not equal to 0. And 2 and 3 gives y equal to 2z. Y equal to 2z. Comparing these two, I got x equal to y equal to 2z. Substituting these values x and y is 2z in the equation 4 in G, I got z square. 4z square 4 gives. Fourth equation gives 4z square plus 4z square plus 4z square equal to 108. So 12 z square equal to 108. So z square equal to 9, z equal to plus or minus 3. Here z equal to 3 only, positive values only I take. Okay. So volume is not negative. So z equal to 3. Z equal to 3 gives x equal to 2z. So x equal to 6, y also 6. So highest volume v equal to x, y, z, that is 3 into 6 into 6. This is 6, 6 are 36. 36 into 3, 108. So the final answer, the largest possible volume of the box in cubic meter is 108 meter cube. 108 meter cube. This is the final answer. These are the GATE 2018 engineering mathematics questions related to the topic calculus subtopic maxima and minima of one variable and two variable functions. If you have any doubt in this topic, then you can ask in the comment section. I will try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.